Hi, we're going to talk a bit more about Sierpinskis triangles. I think they're kind of interesting to think about, to compare the perimeter and the area, and to think about how this is tied to fractals as well. So if you look at just a plain old triangle, if we use an equilateral, it's probably the easiest, but you could use any. If you look at the perimeter and just use a random unit, you have three sides, so the perimeter would be 1, 2, 3. Okay, so that's an ordinary triangle. All sides are equal in this case, so a random unit, it would be 3. What about the area? Now, to make this simple, we're not going to worry about what the units are of perimeter versus area. We're just going to randomly designate this triangle as a unit of 1. Okay, and it doesn't really matter in the whole picture of comparing these two. You'll get a visual on this soon. Okay, so here's our first change so that you've got the first step in Sierpinski's triangles. And what happens here with the perimeter? Now you get to add all the sides of the blue triangles. So if you have 3 sides on the one, then you also have 3 sides on the others, and you get 9. But all the sides of each of these triangles is a half of what you had before. So it has 9 lengths, but the lengths are a half of what it was before. So now it's 9 times a half. So that's where you get your perimeter. What about your area? Well, you now have 3 triangles out of 4. So your original area was a space of 1, and now it's 3/4 of that space. What about our next level? Well, now it's kind of like we have what we had a moment ago, but we have 3 of those little triangles and a yellow triangle in the middle. So what do you have? Now you have each of these triangles, if you count the 3 sides, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3, there's 27 side lengths on the blue triangles, but each one of those lengths is a fourth of the original blue triangle. So it's 27 times a fourth. So that's how you calculate the perimeter. In the area perspective, well, what do you have? Well, you could count all the blue triangles compared to what you would have in total. So what do you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of how many similar spaced triangles? Well, you have 9 blue. Let's count the yellow and add it in. So you have 9 blue plus 1, 2, 3 of the yellow, plus in the middle, 4, 5, 6, 7. So 9 plus 7 is 16. So you have 9 blue triangles out of a total fraction of all those yellow and blue triangles of 16. So you have an area of 9/16. So the interesting part is you keep adding more and more triangles into the blue sections. What happens is your perimeter goes up substantially very quickly because you're adding all the sides of your blue triangles, but your area keeps getting less and less. And it's kind of an interesting thing to think about, that perimeter is going up with area going smaller. Usually they both get bigger at the same time. So that's kind of interesting to think about. If you actually think about it in a pattern perspective, each one of these things is a step. So step 1 is the first row, and that would be n equals 1. Okay, step 2 is n equals 2. Step 3, n equals 3. And down at the bottom, if you played with it a little bit, you can use n as your step number. And then you will know how much you would have for perimeter, because you just plunk in the step number you're in. And you do the same thing with your area. It's kind of covered over, I think. It's 3 to the n all over 4 to the n. So you could decide which step you're on of adding more lines of your triangles, and then you could calculate perimeter and area. The really cool part about this, like I say, is your perimeter increases very fast as your area gets less. The area started out at 1, And by the third step, it's already 9/16, which is less than 1, of course. So that's something to think about. And this is the idea of fractals, where you keep adding, and it's getting more and more detail of the same repeat pattern inside itself, and then repeat and repeat. So hopefully that's kind of interesting for you.